Hello guys, welcome back. Today we will build our first AI agent with the help of Google Development Kit, agent ADK. Okay. Okay, so we are here, right? Uh, Now we will build our first AI agent with the help of Google Development Kit, Agent Development Kit, right? So now first let me tell you something. Alright guys, welcome back, and today we will discuss the how to build your agent, right? First AI agent. Okay, just a second, I have some work. Before that, I will set up. Okay, and view, edit and all. Okay, build tools. Tools is there. An option, compass, eraser, whatever that. Okay. Paper color, I will check black. Yeah. New best fit. Okay. So guys, so before you watch some like any other AI tutorial, right? Where someone will just paste the code and say, look, it's working, right? It's not how you will learn how to build agents, right? So today we will be going to build a real agent, AI agent, that will plans for you, writes, validates its own output, right? And auto-correct itself also. And also we are using completely free tools, $0, no credit card, right? It will be all free. So more importantly, you are going to understand every single line of code also in this, and not just what it does, why it exists. You will have to understand the every line of code also, what every line is doing, right? So what problem are we actually solving today? So let's say we have a chatbot problem. So let me ask you something. So you have used ChatGPT, right? Or if not, you try using it, or any AI chatbot, right? So when you use ChatGPT, it's just answers, right? You type something, it replies, and that's the end of the interaction, right? That is a chatbot. So like you have a query, chatbot, right? It gives the answer. It's the end, right? So in chatbot you have one input, for the one input you have only one output. AI will generate a response and it will stop. Now imagine you asked a very smart junior employee to write a blog post, right? So they wouldn't just immediately start writing. They would think what structure should this have? Let me first draft the outline first, right? Actually, let me check if this outline is good before I start writing. it will like recheck the outline. Then he will start writing, right? Then he will review it. Did he cover everything or not? Did he miss any point? Did he incorrectly identify something? So he will refine it, right, to write a blog post. So this, what is this chatbot? Let me change the color first. Yellow. Yellow is the best here. So a chatbot only answers, right? But a agent, what agent do? Agent will plan for you, act, then check, and then adapt according to it. This is an agent for you guys. So plan and decide also. So the difference, the ability to reason about what needs to happen, right? Take action, observe results, and adjust according to it, right? Is what makes agents so much more powerful than a simple chatbot like ChatGPT you are using, right? So let's go through the framework which agents work on, right? The framework is this: REACT, React framework. What is the framework? What do I mean by this? This is the framework for all modern AI agents, right? So this idea of agents reasoning and acting has a formal name on research, right? It comes from a paper called React. So this was the React paper. So what this means is synergizing reasoning and acting and language models, right? The idea is that here is, so this was the paper name, right? Research paper, React. So idea in that paper was very elegant and simple. Like they said, instead of asking an AI model to generate one big response to everything, what if we gave it a loop, right? Like instead of we are not asking AI model to generate a big response to everything, what we do, we give it a loop. We give the loop to the AI model. Okay. So this is like this. First, it has to reason. Like reason is like we are giving this to the AI model, right? Think about what to do next, like this. This is the reason part, right? Then act. After it thinks, AI model thinks, it will act, take action. Like action on the, it can call a tool. We will understand what does this mean, calling a tool, what is mean. We will understand in later. It can call an API also, right? Or it can run code. After thinking, AI model decide to act. It will take action, either one of them or all of them, right? Then, after that, so this is the React framework, right? React, you understand, React, right? Then we have observe. After this, what agent what it will do? Look at what come back from the action, right? Look what was output of an action. Whatever output to get, the AI model will look into it, right? After that, adjust. Decide what to do next based on what you saw. Decide or adapt according to output, right? Or decide what to do next. And after all of this, right, repeat this, all of this. Let me, right? Repeat until the task is done, right? So let's make this concrete. Like imagine asking an agent what is the weather in Tokyo right now, right? So we are asking agent weather in Tokyo. This is the question we asked to agent. What will agent do? So region, first comes the region part, like. So to answer this, agent will go for like I need current weather data, right? It will think of that. I cannot know this from any training, right? It has to know the real weather data for. So what it will, this is the reasoning part. What is the real weather data, and I can't do with only training, right? So it needs data. So what it will do, I need a weather API tool, right? It's need a weather API tool, right? It will need a weather API tool. Then it will act. Second phase. It will call the weather API. Call weather tool, right? Like say it can give like I want to know the weather of Tokyo. This act will give some output. After this, it will observe. What it will observe? Let's say whatever the output like temperature, right? Like 18, let's say condition, cloudy, rainy, anything, right? Like it. Humidity and all. So after this, it will after observation, it will reason again. It will do, like I have data, what I need, and I can answer now, right? It will decide I can answer now. Then it will answer. It will generate the answer with the help of AI model. It's currently 18 degrees Celsius and partially cloudy in Tokyo, or like it's that much percentage of humidity there, right? So what happened now, right? Guys, what happened in this case? The happening was agent did not just guess things. What he reasoned about is like I will not generate random numbers about weather. He reasoned about like I need some real data to tell the weather. Then he think like where I can get the data. He thought like I have a weather API tool which can tell me data of give me data of the weather of current weather in Tokyo. So he decided to act to load the weather API, right? So this is the react. What we do? React, right? Reasoning plus acting, right? So key terms from this section we can say like we have react, right? It's like reasoning plus acting. Then we have tool. We need APIs, right? Other tools, functions, right? and we have reasoning loop. Then it's like think, act, observe, then cycle through it like this. Okay. Okay, guys. So this is the framework how agents work. React framework. Okay. Now we will discuss uh, types of agents. Right. So you can say like every agent is different. So we have some pattern to use agents like right? We have three patterns generally. So we use them situation by situation. Three patterns we use like we use agents in three patterns like right. What is the pattern? Pattern one. Pattern one is sequential agent. Right. So what do you mean by sequential agent? Like a sequential agent will run a fixed list of steps in order, right? It will run steps. It will have a fixed number of steps, and it will run them those steps in order, like step 1, step 2, step 3, right? It will never go from step 1 to step 4 directly. It will always follow step 1 to step 3. It's like a fixed, right? So what it does is it runs fixed list of steps in order. For example, step 1, then step 2, now go on like this. And one more thing, it never deviates also. It will never deviate from order. This is called the sequential pattern of agents, right? For example, in assembly line, right? How assembly line, how we manufacture products, right? Let's say, for example, to build a car, we have to attach a framework, then engine, then install the doors, then after that we paint, right? We cannot paint the car before the frame exists, right? So when we use sequencer, so we have to use this like when we have, so let me write it also. So it's very dull, let me write. When to use. When to use this. So when we have strict order dependencies, right, of tasks. Like each step require previous step to finished, right? We should not use this sequential pattern when we have flexibility, like one step is able to it depends on the dynamic decision, right? It can run also parallel. So we only need this when strict dependency there. Then we have other pattern. Pattern 2. This is called the reactive agent. Right. What is this? So what is the reactive agent? Reactive agent will look at the current situation and it will decide what to do right now. Like each decision it will make in that moment will only be based on the current state. So reactive, let me write the definition. Should I write or not? It will take much time, right? We will find this very. So I will just go through the theory, right? So let me repeat myself one more time. Let me write in short. It looks at current state and decide what to do next. Right? Let's say analogy, you can say if you have a billing question, right? They transfer you billing. If you have a technical problem, they will transfer you the tax support. Like you have a technical problem, they will give you the tax support. If you have a billing problem, they will give the billing, right? So if it's a simple question like general query, they will the help desk will answer to themselves. So when to use this, let me write this also. It will use when tasks are dynamic and unpredictable also. What do I mean by that? So agents need to make different decisions each time based on what is object. Like if answer is yes, then different decision. If answer is no, then different. So dynamic, unpredictable. Then we have to use the reactive, right? So then pattern 3 is deliberate, or we can say them as a planning agent also. What do you mean by that? A planning agent, it will pause right before acting. What it will do? It creates a full plan before and sequence of steps, right? And then executes that plan. So before taking any action, it will plan it out, all the steps, then it will take action. Like planning a trip, you do not randomly book a flight on day 1, right? You pick your dates, choose your destination, find flights, what flights are available, then book a hotel according to your budget, plan activities there, then you sketch the whole plan first, then execute it step by step, right? So when we use this, what it does, plan before acting. When we can use this, so when tasks have multiple interdependent steps, right? Like let me write it here. When tasks have multiple interdependent steps and doing them in wrong order causes failure. Right? So, which pattern we will use in this tutorial is we will use all of them, right? We have our overall flow, write, plan, write and finalize. which is sequential. Then we have our retry mechanism also, which is reactive step, right? Well, then we have our root agent that coordinates everything. It's like planning agents. It gets the topic and immediately lays out a plan. First I will plan, then I will write, then I will finalize like this. So all of these patterns are combination, right? We combine these patterns. In real production, this is very common to combine all of these patterns. So let me come to what are we building today, right? Now today we are building a blog writing agent. Like we are building a agent which will write a blog. You give it a topic, that's all you do. It handles everything else, right? Like you tell this, you write a blog post about like top 10 use cases of AI agents. What it will do? What agent will do? Our agent, it will generate a structure outline, right? Title, intro, then 4 to 6 sections, and then conclusion, right? So then step 2, it will validate the outline automatically. Is the structure correct? Does it have all required parts or not? Right? If it has, then move on. If it does not have all this, then it try step 1, like generate structure outline and plan everything, right? We can like hardline it, like how many times we are trying to loop this, right? Then it will write full blog post from the outline. Step 4 is validate the blog post automatically also. Like does it have an intro or not, all sections are there is or not, right? Is it their conclusion, is the writing clear or not, right? Then if it is not, then retry step 3 up to 3 times, like it will retry to write the code. If yes, then move on. Then what it will do, generate 3 alternative titles, 2 tweet length hooks, right? So you get it polished, validated production quality blog post. So okay, so let me go for. I will explain this also later. Everything when we build this. So let me lay out the architecture before we write any code, right? So let me write the architecture here. What will be our architecture? We will have a first we will have a root agent, right? What we will name this a blogger. Let's see. We will have a root agent which is blogger who writes code. What it will do? It will receive the topic, right? Right. Then after receiving, it will coordinate the full flow. Right. It will check like tool availability, which tools are available or not. Right. This is the root agent we have. After this, let me after that we have this we have tools, right? We have a planner tool, like it's also agent, right? Agent, planner agent. We have a writing tool also, right? It's all agent. These are all agent. like this, right? It will look for tools. It have then this planner tool, agent tool is what it will do. Okay, it will go for further. It have more agents. It has a loop agent, which is like a robust block planner, which is we named it, right? One other loop agent is this. It has a robust blog writer. This is also a loop agent. Loop agent which will perform the task after all, right? After this, guys, we have we have another agent which is a block planner. This is agent. This is not loop agent, right? We have blog writer. This is also agent. It will plan. It will write it, right? It will also write, right? After this, we have blog outline. This is the planning, right? Sense state, we have it. We will store the outline here. After it writes, we have our blog post, right? We also save it as session state. Then after all of this, we have a outline validator. Like if we want to, if it is outline, it's correct or not. We have a post validator, right? We have to OK or retry like this. This is the architecture, right, guys? So this is the architecture, right? So what will happen is this will take place first, right? This validation part. This flow goes first. Let me take this. This will go first, like this. After this is this. After this, right? If it is okay, if it gives okay, we go for the writing loop. Then this will take place, right? This is the output. Okay. So for this to understand, we need to understand some things. I use the term like this session state, right? What is session state? It's like shared Python dictionary that all agents in a session can read and write. So when a blog planner, right? When this writes an outline after this, right? Blog outline. It saves it in a session state, right? Then blog writer can read it from there, right? After this gives OK, so blog from this session state it can write it, right? Read it. So they will communicate this from it's a dictionary, right? Session state is a dictionary. So you can remember that the agents will communicate through the shared memory, never directly with each other, right? And one thing I also use the loop agent. What is loop agent here? So it's like a workflow agent that runs a list of sub agents. I will talk to you later what is loop agent, but I'll just remember this right now. What is loop agent? It's a workflow agent that runs a list of sub agents repeatedly, checking after each cycle like whether to continue or stop. In our case, it will like run the planner, run validator, if retry, loop again. So this is loop agent. What it will do? This is the loop agent. It will run the block planner, right? Then write that. If it is retry, then loop again. This is what loop agent is. What is agent 2? What is agent 2, right? Agent tool is a wrapper that lets you treat an entire agent pipeline as if it, like, it's a wrapper, right? Wrapper is that it will let you treat the entire agent pipeline as if it were simple function code. The root agent calls planner, right? Planner tool first, and does not know and or care about like inside there is a loop agent with 2 sub agents and retry logic. It does not care. It only care about I have to call the planner tool first. So this is the agent tool. Planner tool. Okay. So now I said like to build this. Now we will start implementing this. So before this, I need to tell you like we will use all the free tools which are available, and we will not use any extra tool which cost you money because I also can't pay any money. So yeah, let's okay. So before we touch any code, let me be crystal clear about like we will use some tools, right, to build this. So let me outline those tools first. Then we will go further about before after it. अरे भाई हाँ तो I think it about I don't know what happened, but let me restart this again. Okay, I don't know what happened, but okay. Please reflect here. Or is there any calamity you want, guys? This color. Okay. We going to go for this color also. This is also good for you. Right? Yeah, so whatever. Okay, so what tools we will use, right? Tools we have one tool we have is we will use this Google AI Studio. What it will do, it will provide a free access to Gemini AI model. Why we need it, I will tell you why we need it. So we have to sign up for this, and it will provide free access to Gemini AI model to us. Then second tool we use Google ADK, which is Agent Development Kit, right? What is it? It's a open source agent framework we have by Google, right? Then we have a Python. We need Python. You all know Python programming language there. We use UV. What is this? It's a Python package manager. It's very fast. So fast Python package manager. Manager here we have. Then we use the ADK, web UI. Why is this? It's a local browser interface, right, for testing. Okay, so it's like it's built into ADK only, so there is no separate for this. It's open source, all are free. This is free and open source, this is free open source, this is free open source. This provide we have free tier available for this, for API. Okay, so these are the tools we will use. So to get our free API for this, we need to Google API, right? So what we need to do is, guys, let me tell you, let me show you also. If I have Google open, no. Okay, that's not a problem. Let me open my Google. New window, no. I don't think I should need. Just open this. Okay. So guys, let me tell you, we have this. We need to go to this website, like https go for aistudio.google.com. We go here, where it is. This is it, right? Okay, we go here because I already signed in. If you are not signed in here, so you can make an account, Google account or Gmail account, and sign it here, right? After this sign in, you go for like where? Okay, go for the home page first, and then go for like let me tell you, go for this Google account here, link in API key, manage membership, like something like that. Okay. No, this is not what I was. Okay, let me see. Let me drop down this. No. Settings. Okay. Okay, so we are go to dashboard. After dashboard, go to API keys, right? So what you can do, you can create API key here, like anything, like Gemini API key like this. If you have Google account, so let me let's say for agent, name of for agent, right? Project is like I can create my new project, like what project? Build agents, create project. I will not show my API key to you, but yeah, I will get the API key. You can copy that from there, right? Okay. Let me hide it first before from you. Okay. I will tell you if I got that or not. Okay, I will click on the build API key. Then after that, I will have my API key also. Alright. I will show you after I get it. Okay. So guys, okay. So I get my API key here. This is my API key. I can copy it from here, right? Okay. So you can do that also, right? So that's it. You have now free access to Gemini. It's a free tier limits. It have you can do 15 requests per minute to it, and after that you can do 1500 requests per day to it, right? So these limits are more than enough for you to build and test everything in this tutorial. So security rule for this guys is for us is you should never share your API keys, right? That's why I hide it from you. So never share your API keys publicly, never commit it to GitHub also, right? Never paste it in public chats. If you accidentally expose them, like if you accidentally post it publicly or expose them, so what you should do is go back to the AI Studio and delete it there from there. You can delete it from there and create a new one, right? You can delete it from here like this, delete that, right? Okay. Then now first we have to install UV. Because I am using the Linux, I can I think I have this UV I think already. Let me check. So let me ask this to Google only. How to check if I have UV installed, right? So UV version I can check here in my terminal. Let me see UV version. I have my UV version, so there is no need to install for me. If you want to install, what you can do, you can run this command. I can also run this command. There is no need. So that's not very. Because I am. Let me tell you this. You can run this command. Paste. You can search it here, right? This is for Macs or Linux. You can run this command in your terminal for Mac users and Linux or Ubuntu users, and this you can run in your PowerShell for Windows users, right? Or if you already have Python installed, then you can quickly install UV using pip command, pipx command. So you can install it like this also. Alright, so that's not a big deal. You have UV here, which is for Python package manager, and if you have Python installed, you can also go for this pip install, right? It is fast. It is not that fast than the okay. So why preference wise, what you should do is you should install like this. If you already have Python, you should also prefer this, because what is this? UV will install packages 10 to 100x faster than PIP here, because it is written in Rust, right? UV is written in Rust. So what it will do, it will automatically create and manages your virtual environments and isolate Python environments that prevents your project packages from crashing with each other on a machine. So you can install it globally for you, right? This is what professional Python developer will use 2025 and 2026, right? Okay, so now we will create our project directory here, right? My first agent, let's say we have we can use like this terminal, make directory my first agent, right, like this, and after this we go for this like this. Okay, we are under this, and make directory for this also. We have a blogger, right? This will be okay. We create some file in this blogger. We have in it py initial files, right? Then we have touch right, like this, and we can create a environment file. You can see it here. We have memory file, we have these two files. Okay, all that. This is the directory structure we have. Now we set up the environment first before anything, right? Okay, what we will do, we will select our model. What is our model, right? Model we have is Gemini. We will use this 2.0. This is a flash version here, right? This is our model. Here then we write our Google API key here, right? Like what you will do, you will paste your actual API key what you created. So I will paste mine. Let me hide it from you because we are live streaming, so I cannot expose my API key. I will copy my API key from here and I will paste it in my environments, right? Let me do this. Great. Okay, and I pasted my API key here. I pasted it, and okay. Okay. Now I can show you my screen. So there I have pasted already my API key, right guys? Then after this what I can do, so why we need this env file, right? Why just not give API to the agent.py file, right? So for this you can accidentally push this file to GitHub, right? So anyone who sees it can use your API key. This has happened to thousands of developers. It can be expensive for you, right? So env file is a standard practice here to put secrets in a separate file, right? So add .env to your git ignore, so it never gets committed, right? So we create a .ignore file also. Let me go to git ignore .env. You put it, and git will ignore this. It will not push it. Right? Load your values at runtime. This is what you will do, this you will load these values at runtime only. Okay. Then we will install some dependencies. Okay, so do we have any Python PIP installed? Right. We will use ADK global agent development kit. We have to install, right? Python .env. So I need to create a virtual environment, guys, for Google. So let me do one thing. I have a virtual environment. I will look into it. So source is less home global. You can create a virtual environment for in your project also. Just let me, okay. So let me tell you how can you do that. How can I create my virtual environment to run PIP install packages, right? Okay. How can we create our virtual environment, right? Okay, so what happened? What is the response? What is the okay like this? No. This is not how we do. I have also some idea, so let's not. Okay, we can go for this. UEVEN, we can go for this first, right? Okay. Here UV VENV. Okay, using C Python. This is our VM created. After that, what we can do, guys, is okay. Source. Okay, let's say. Let me tell you now. Okay, so after you create this environment, you can see like you have this bin folder, right? You have this activity. You have to run this file, right? So how can you run this? You can run this like a source dot venv slash bin. Then you have to run this file. You have created this virtual environment now, right? So this is your virtual environment, guys. Now you will work under this environment. You can now install this PIP. Okay. PIP. Okay. Let me. What is this? Let me. Okay. Because it was very long, right? It's very long. Oh, doesn't matter. Okay, sir. Let PIP. Okay, so install the Google ADK, right? Python dot env, right? What happened now? Dot env, no. Okay, let me tell you guys, because this is not Python environment, right? This is not Python environment. So what we will do, guys, is we will delete this environment, and after that what we do, source slash home slash we have global UV, then active. I have this environment globally. Okay, so this is my agent. Now I can run this. Why it is not running? Installed by system, try installed by the install. Okay. What happened? So I can take help from this. Okay. Why is this error? Okay, so let me see, guys. Okay. Oh wow! Wow! What? Let me ask you this thing. This. This. Okay. So, let me run this command first. Okay. Okay. Yeah. Let me kill this terminal first. Delete and okay. I am running this. It's again giving me the error. Now I can ask it. Okay. Now can I ask the Google why I am getting this error again? Now it will tell me what is that. Okay. Folder message internet from source your agent build your agent ADK. Okay. Okay, let me see. Whether it work or not. Okay. This is my thing, and after that, what I should do? Okay, let me. What happened now? It again works. Okay, guys. I'm getting this error again. Let me handle this first. This is not your environment. Your suggestion is that this environment state. This is okay. Okay, let me rename this then. Let me rename this. Okay. Let me rename this like this. Okay. Like this. And let me open here. studio code. Okay. Oh yes, I checked this also. Let me go for this. One more thing. Yes, I had this right like this. Okay, so sound because I am trying this right, guys. Let me show you. I have this here. I have this. Okay, this was the part, right? Let me do this. Okay. Here, so A should be activate. Okay, now we have our environment. Now I can run this. Install Google ADK Python right. Now it's on. Like this. So the warning was like you should always use your environment, right? So so this is I am using the global environment, but I can use this environment also, right? Like this. Let me show you. I am using my separate environment, but I can use this environment also. So env then activate, right? What happened now? Okay, it's not showing this right. Okay, so what happened? Okay, so source dot env then activate. That is the same. Okay, it will come after like this. Okay, alright, I don't care. Now I can install Google already. Okay, can I do this? No. So because we are using UV build, right? So UV we can now this Google. This is another command. ADK Python dot this is faster. Okay. So for this I have to create this file. Okay. Let me create this file. What it is asking? project.uml. Okay, so can it go for this now? What will happen, bro? What is happening, guys? Why I am getting these errors? Okay, I can use this command. Oh, we have to use, okay. Alright. Okay, let me initialize it. Let me do all things, bro. UV image. Wow. UN. UV input. Now what happened? Oh, now file exists. Okay. Let me delete this. So delete it. Okay. Now UV input. What happened now? Oh wow. Wow, wow. Guys, did you see what's the problems now you facing? Stupid problems. Like this guys. UV init. Okay. Now it's like a Python version and all these files are created. Okay, all the required files. We will go for them, and after that, what we will go for? This okay. The UV add Google ADK Python.net .env. So we go for like this. UV add Google DK Python .env. Okay, now it's running. The ADK is now. We are downloading this Google development kit. Okay. After that, what we are doing? We check like DK version now. Okay, we have this version. Okay, like first I should go for this. So we then ADK version whatever. Let me do this one. UV add Google DK version. Okay. What's happening now? Now what is this result? I'm just trying to go to the AI agent group. Okay, whatever happened. It's just warnings guys, okay? Let me check the ADK version. I'm just trying to get the versions, it's not. What is going on guys? Okay, now we have the version now here. Okay, so we have this, and Google AD Google Agent Development Kit is there, right? So this is the entire framework we have. We have agent class, loop agent, agent tool, ADK web UI server, everything else we will use, right? And what is Python.env? It's a tiny library with one job. What is this one job? Is like it will read .env file and loads its key value pairs into Python. So wait, just So guys, let's start coding now, right? We have to code this. So first we will go for this file, open the logger and agent.py, right? We have this file. What we will do? First line is import the OS. What it will do is it will give us access to the operating system functions. We specifically need like there is a function dot get environments dot os dot get env which will read the environment variables there at okay. So we will use that function for getting our API keys and model names from the .env file in our code, and then we have import datetime library. We use this letter to inject today's date into the root agent instructions, right? Without this, the AI has no way to know that what day it is and all. So which matters when it write contents that says like, okay, so think is like as of date today and references like that, right? Current events, and then we will import from .env import load .env, right? What it's showing is it will import the load.env function, this function, right? Why we are using this? When we call this load.env function, it reads our .env file and makes Google API, right? And make the Google API key and model available to the this get env function. I will tell you more about this, right? And next line for us is like from Google ADK agents. Like what we will import from here? Import agent and loop agent, right? What we imported two classes here. Agent, which agent class is a building block for every individual agent in our system, right? And this is, and then next is a loop agent. It's a workflow agent that runs sub agents in a loop. I told you earlier also, and we will talk about it later also. And after that, we will use from Google ADK tools. We will import this agent tool also. We discussed it. What it will do, import the agent tool and agent tool module which contains agent tools, right? The class that wraps the entire agent as a callable tool, right? I will explain them later also. Then what we will do, let me Okay. So what we will do, let's say we have this function load .env. We will run this. After this we have, it will load the environment variables model us dot it will make the environment variables available to us. Then we have this function of OS, right? Now we are model. Which model we are using? Gemini 2.0 flash exp, right? So this function, right? This function, this will read every line from your .env file, right? The API keys, the model you are using, everything, and it will load them into Python's environment, right? Load from env environment. Okay. So what is this doing? Loads .env into Python's environment. We can say that like this. Okay. After it, this is like we are .env like this, and to model and this. Okay. Okay. This model, this will return the model, and okay. So while we are using the model name as model here, right? So the thing is, so what this line will do? This line will do what? It will read the model environment variables, right? And if model is not set in your env, this is the default value. If env is not set, there is no setup for this model. So what it will do? It will set this. It will falls back to this model. Okay. This will prevent the state crash. So why we store this here in model? Right? So once for each agent we have this hard-coded string, right? This model. Okay. In each place and later wanted to switch to a different model. So we would have to find and update 5 separate lines, right? So if you so what we do? We get we only change this model for every year, and this model will change for all of the agents. So by storing it in one variable at the top, we change one line and it update everywhere. So this is called the dry principle. Dry principle. Okay. Principle. Good. Okay. Like dry principle is like, don't repeat yourself. DRY. Okay. DRY. This is one of the important principles in progressive software development, right? So we don't need to write it here. Okay. So first we write code for agent 1, right? One is the block planner, right? We need to name this. Okay. Let me write the code for that. Then we can understand each and everything, right? So let me write the code. First line is this. Block planner we have this agent, right? Okay. First we have this name is equal to blog planner. We can give any name to this. Okay. So blog planner is his name. Then we are using which model? We are using model. And what is the description of this? Right? Description of this is like what it will do. What defines this agent? So it will create a practical, right? Schemable outline in markdown, right? Okay. This is what this agent do. This is a description. What are the instructions for this? This is this identity of this agent, right? Description. Okay. And we have instructions. Okay, instruction only. Okay. Okay, like this. And what are the instructions? You are a technical content strategist, right? Produce a clear markdown outline. Okay. Outline with title, right? A short intro will be handful intro, then 4 to 6 main. Okay. 4 to 6 main sections here, right? Each with 2 to 3 bullets, right? Then after this it will conclusion. After that all, if always context, right, exists in state. So what do you have to do? Weave in specific sections, or we can say snippets, right? Return only the outline and mark down, right? Okay. Then after this we have output key also, log outline. This is how we define an agent, right guys? We have a unique name for this, so we can identify this agent within the system. So what ADK will use, where ADK will use this name, it will use the log messages. So you know the which agent is running right now, and it will be used for trace the output, like which agent failed, right? So okay, and it will trace the output in development ADK web UI. So choose the name that clearly describe what the agent does, right? You should not like randomly ABCD. You cannot write. You should not write. Never write like this name, right? Then model, we select the model here, right? Okay. Okay. We select the model here. This model, the model we are selecting. Okay. Which AI model powers this agent's brain? We pass our model variables from above. So this is the Gemini Flash model we are using here. Okay, so every agent in our system uses the same model, but each agent has completely different instructions, right? Which makes them behave differently. So description is like a human readable description of what this agent does, right? So this is not just a comment for you to read. In multi-agent system, the root agent reads the description of all available sub-agents, right? So it can decide which one to call for a given task. So a clear, accurate description is like better routing. If we have clear, accurate description, then root agent will clearly route the decisions, right? Then after that we have the instructions. Why we have these instructions? This is the most important parameter here, right? This is the system prompt for this specific agent. Think of it as a job description you write for an employee, right? It tells you like who they are, right? Like who they are, like you are a technical assistant or not, then what to produce, like a clear markdown file it will produce, right? Like this. Okay, produce a clear markdown file with the title and like this, right? Exact structure of required, like how you what is the structure of the markdown file, okay? Then what context to check, like so if a code base context exists here, we have checked. Then then after that we return the output, return only the outline. This return only the outline markdown, okay? Okay. So notice how specific this is. It does not say write an outline. It says exactly what the outline must contain. How many sections, not like some section. And what format to use, like markdown or that. So this specificity is what makes output reliable. Okay? So reliable output is a key here. Then we have output key like below outline here. What it is, like when this agent finishes generating its response, right? So ADK automatically saves that response into session state, the shared memory I told you, right, earlier. So which all of them use. But this shared dictionary all agents can access, right, under the key of blog outline. So this is the key blog outline. Under this key, all of them can read. Think of it like this, the agent writes its output on a shared whiteboard and labels it, right? Okay, then now we will define the another agent, okay? Okay, after it, agent 2 we have, agent 2, what this agent will do, okay? Let me define this listen checker. This will take an agent, define initial file, okay, super, define another, we have a name called outline validation checker. Then we have model called model, right? Then we have description also this for this. I'll tell you everything what is all about. Okay. First, let me write this. All of this. What it will do? Description. Description is like it will validate that the outline is usable or not. Okay. Okay. Then we have instruction. Instruction for this agent. Okay. Okay, make sure instruction is like triple quotes. Check the outline and state which are the key, this key below outline, right? If it has a title intro 4 to 6, we have to verify everything, right? Sections, right? And a conclusion, right? Respond exactly or okay here, right? Otherwise respond exactly, retry and list missing pieces also, right? Okay. And after that we have this output key, which is validation result, right? This is how we define these guys. So why we are using a class here instead of a simple variable, right? Simple variable also work in ADK and also class will work in ADK, but so class outline validation like checker is like every time you write outline this function, right? Every time you call this class, right? With parenthesis, you create a brand new fresh instance of this. Okay. This matters in loop agent because each loop iterate should start with a clean state, right? So we need to instantiate every time it. So no leftover state from previous iteration, right? So a fresh instance will guarantee that we are not using any previous state. Super init like this, why we are using this? Okay. Okay, let me check it. I think okay. This is how we do, like this. Okay. So this like that. Why? Okay. Okay. So everything that we make, we have to do this now because we identification must be correct, right? Okay. So it's a standard Python. Like what it will do, it calls the parent class agent. This is the parent class agent initializer with our parameters, right? What are our parameters? These are Super is this, agent is this. This will call this class without these parameters. Okay. So this is a new agent we have. Okay, with these parameters. Okay. Right. So the class inherits all the agent's behavior. So we are doing like respond exactly like this, respond exactly like this, right? What exactly is doing in this work? So the loop agent need to programmatically read the validation result, right? And make a decision after that. So like it will decide like should I loop again or stop. Right? So it does this by checking the value saved in the session state, right? Under validation result. It will check like is this the value of validation result right? Okay, so is it okay or is it right? It will check that. If the validator said yes, the outline looks great instead of just okay, the loop agent cannot reliably parse it, right? So it's looking for the specific string which is okay, not a sentence. So this is a fundamental tool of building agents that communicate programmatically. So we are trying to make them more deterministic as possible, right? So when an agent's output is going to be read by the code, right, not by a human, so the output format must be exactly specified, right, exactly constrained also. So like binary outputs, okay, retry, yes, no, pass, fail, 0, 1 are the most reliable for programmatic decision making, right? Then output key, we have this output key for this agent. What it will do, it will save the agent's response okay or like retry, right? To session state under validation result key, the loop agent will check this key to decide whether to loop again or not. Now we will design the loop agent here. Okay. Loop agent, we will design the loop agent. We have the robust log learner into loop agent. We have his name. Okay. Engine. Okay. Wow. Okay. Like this. We have this name for this, which is robust. Name should be unique. Below learner. Then we have description for this, right? Son. It does not need model because model will be there for specific agents, right? What it will okay. What is the rise learning if validation fails, right? And we have sub-agents for this. It will run the sub-agents like this. We have a globe planner. We have then outline validators. Okay, validation checker we have, right? Okay, outline is a checker. Because this is a class, right? So we are creating the instance of that region right now. So this is I hope you understand. And next iterations we can define here, which are 3. Okay, like this. This is the heart of our operation application, right? So let's dissect it like sub-agents like this. This list will define what loop agents run each iteration, right? it will run this block planner, then outline validation. Okay. So at every iteration, it will run this agent first, which will generate the outline. That outline will be saved in the session state under the key of this block outline, right? After this, this will run this validation checker. This validation checker, what it will do? It will read this block outline from the session state, right? After that, it will check like if it is okay or not. It will save this here right now. Then it will check. This will check like okay or not here, right? Validation result. Then loop agent will read this validation result, right? If it is okay, exits the loop. Retry planning if only the validation fails, right? Okay. I'll go back to step 1 if it says retry. So this is the safety valve for next iteration here. Because even if validation never passes, right, this prevents the infinite loop in case of the model consistently produces bad outputs, right? Okay. Alright. So why this pattern is so important to you? So without the loop, if AI agent generates a bad outline, right, on the first try, you get a bad blog post. You just see poor quality after that, right? And you like with the loop, the system catches its own mistakes automatically. It self heals itself, and user always get a validated output. This is like generate, then validate, then retry, right? Pattern. Well, once you understand it, you will see it everywhere in production AI systems. Okay. Like code generation agents that what will do? They run the code and retry if it fits, right? Data extraction agent that validate JSON schema and retry if it like malformed, right? Like summary agents that checks length requirements and retry if too so. Production tuning, right? So if we are said like more iteration, like so more iteration will have more API cost, right? More cost for it. Okay. Then after that, so we have to have acceptable latency for this. So each iteration will add 2 to 5 seconds of depending on the model latency, right? Now we will write the last block writer agent, right? We have this agent called block writer. Okay, we have block writer as an agent. We define that. We have a name for this, which is block writer. Then we have model for it, which is model. Then we have description for it, right? Which will writes a technical blog post. This is the description from the outline, right? This is the description for this. Then we get the instruction for to it. Instructions on instruction. Okay. What are the instructions? It will write a complete markdown article, right, from the outline. Then where is the outline? Below is the, we have to read it from the this the session state, right? Here so we have some guidelines also, like what are the guidelines for this? Guidelines are what are the audiences for software engineers, right? Skip basics and focus on practical insight, right? Then what it need to do, explain both the how and why, right? This is how you give instructions to an agent. Then include concise code scripts when helpful, right? You need to learn. Then it can what it can do, follow the outline, right? Structure like H2, H3, right? Then output only the final article and mark it down, right? No fence around the whole post. Here are some instructions and the guidelines for this, right? After this, there is a output key for this is like we can write in a separate key for this. Okay, this is our third agent. Same structure is a planner, here guideline. From outline document, it will read the blog outline. It will test the what it will. This line does the two things, right? Things are tell the agent where to find the outline. This blog outline, right? This. Okay, and this will tell where to find the outline, and after that ADK injects session state values into the agent's context automatically. So when the agent runs, it can actually see what the planner wrote. Okay. So what ADK do? ADK inject the session state values, right, into the agent's context automatically. So when the agent runs, it can actually see what the planner wrote and code. Alright, so guideline injection, why each line matters, because these guidelines these are self-explanatory, right? Okay, then this line is important. This will tell like keep the article consistent with the plan. Without this, the writer might reorganize sections and use different headings, right? So headings are more as to the consistency there, and output only the final article after. Without this, the agent might wrap everything in triple backtick code and fence, making it unreadable. This exploratory constant prevents that. Okay. Then after that, it will save this flashed article to session state under this key. The validator and root agent will both read this key. Okay. Now we are defining the validator for the blog post. Right. Blog post validator we have. Okay. Class we have blog post validation checker. Okay, agent we are taking agent here. We have okay self and we are taking the super. Okay. Alright, what is the name for this? Name for this is like a blog post validation checker, right? Then after it is we have model equal to model description is like this. Oh, the description is this. Oh no, description is like this only. What it will do, validates the final post, right? Okay. Then we have instruction. We are writing the now instruction. Okay. Alright. Then what we do, like check this below blog post, and the blog post is listed for intro clear sections, matching the outline, right? Then it has confusion or not, confusion, and technical clarity. If passes like respond okay, else respond with retry with the specific fixes, right guys? Okay. Then we have output key, right? Validation result. Okay. Like this we can do this, and because it is using the same, right, validation result here. This is intentional because both validators write to the same slot in the session, right? The loop agent always checks validation result to make its decision, right? Regardless of which validator wrote it, right? This is a clean design. The loop agent does not need to know which specific validator name. It just to check if the key makes a decision or not. The checklist validator, okay. Okay. Now more technical part, guys. We have wrote this, and now we are writing this next agent, which is robust blog writer loop, right? So this is for This is again a loop agent. As you can see from here, we imported two classes, agent and loop agent, so we are using both. They need different parameters for them. Name here, it will be common, robust, blog writers. Then after it is a description for this, right? What it will do, it will try writing if validation fails. Then it has some sub-agents, right? Like blog writer it will go for, then blog post validation checker it will go create the instance for this, right guys? Then we have max iterations equal to 3, right? Okay, so this is the exact same structure as the robust block planner, right? What it will do, it will call the right robust block writer, right? Then it will check for validation. If it is fails, then again call this, again validate if it is fails, call this, validate this, and max 3 iterations will go for. Now we have to wrap these agents, right? So we have to wrap these agents as tools. This is a very critical step. So we have a planner tool which will be like agent tool. What we have, agent tool, we have one agent is this agent is a robust block planner first, right? Then we have this agent writer tool, right? We have agent tool dot agent tool agent is equal to robust writer, right? This is how we are wrapping this, like wrapping agents as tools, right? Wrap them. Well, we imported this tool also, right? Agent tool. So this is what is a tool in ADK, right? Tool is anything an agent can call to make an action, right? So agent can call this tool or this tool to take any action, right? These tools are usually Python functions, like for web query, right? Like to search the web, right? To save to database, like that. Okay. So the agent can call these functions during its reasoning loop and get back results and use those results to decide what to do next. Okay. So what does agent tool do? Agent tool this this line wraps an entire agent pipeline as if it was a simple tool function, right? Like one is planning, then writing, just simple as a function, right? And it will behave exactly like a function it can call, right? The root agent does not know, right? That does not need to know also that inside planner tool that inside planner tool there is a loop agent containing sub-agents with retry logic and such. So root agent does not need to know that. It only need to know that I have a planner tool, I have a writer tool. I need to call it like that. Right? So why does this matter, right? Encapsulation. Why is this encapsulation matter? So imagine you are a manager, right? So your job is to coordinate the project. Okay. So you don't need to know whether your outline team is 1% or 10%, right? So whether they use spreadsheet or whiteboard or how many drafts they go through internally or not, right? You just say team, I need an outline by Friday. They handle the rest, right? You get the outline. So what agent tool does is for the root agent. It gives the root agent a clean, simple interface to complex internal workflow. So in large production systems, what it does, you might have agent tools that themselves contain other agent tools many layers deep, right? So a root agent might call tool A, which internally invokes another agent which calls 3 tools, right? Which each invoke other agents. Root agent sees none of this complexity. It just sees a single tool called as a result. Okay. So the root. Now we define the root agent, the orchestrator we say to this. Okay. Now let me design the root agent for you. Okay, let me write this agent also. Okay, so after it, let me define the root agent. Okay, root agent. It's also agent, right? So name is in architecture we define this name. Name is blocker, right? Then it has a model called model. Then we have a description, which is a minimal multi-agent logger that learns and writes. You can say that step by step like this. Now we have instruction, right? Okay, so instruction is not like this in here. Instruction are like this. Okay, so if the user gives a topic, okay, so what you have to do, one is call the planner tool to generate the outline, right? The outline, then to call the writer tool to produce the full draft, right? At 3, what it needs to do, and with 3 alternate titles, and to tweet length hooks. Okay. Address and date also, like date time or date time now, dot time. Okay. What is the format of this? Format of this is like y, and then this is okay. Alright, then we have our tools, list of tools. We have learner tool, we have writer tool. Okay. This is how we define our. Right, what is that? Right, I think this is good. We have this, let me more explain this. We have this name for this agent, root agent, and we have model, description, like every string format here is like, it evaluates the Python expression inside it, right? Inside this, it evaluates these expressions inside this, okay? So we have the function, okay? This can be called this function, okay? Like this. It will evaluate for 2 days date, like what is date today? 15th June of 2026 or 2026, June 15th, like this. Okay. Why to inject the date? Because Gemini training has a cutoff date, okay? Without telling it like current date, it might say as of 2024 like that. So when writing content about current technology, injecting the real date makes the content accurate, okay? Then we have the number call, like number in force order, right? Like 1, 2, 3 like that. So until step 1 is done without the numbers, the AI agent might try to write the post before generating the outline or skip steps entirely. So number instruction create predictable and reliable sequence of behavior from an agent that is otherwise flexible, right? And these tools like this, why these are here? This is the root agent's complete toolbox because it can only call these tools, right? Plus generate text itself. So for the title and hooks in these 3 steps, step 3, right? Okay. By limiting the toolbox, we limit the agent's action space, okay? It cannot randomly decide to search the web or call the external API like that or do anything else unaccepted. It only options are call the planner tool, call writer tool, and generate text directly like that. Okay. Okay, so this is the generation. This is, in this case, it will generate the text directly. So this is the principle of least privilege applied to AI agents. Like, give agents only the capabilities they strictly need for their job, right? Nothing more. So let me go through the code file and tell you one by one. OS for accessing the on. Okay, so let's verify the code. Complete all together reference. Here is the entire blogger like the file. Okay, so we have the date time here. You know why date time we did it, and with this .NET load the environment variables, right? From the .env file. Here this is the env file. I will not show you. And this for agent and the loop agent libraries and then the agent tool. Okay, to wrapping up the agents and making them like okay. So load the so what it will do, this load.env, this will load the file. So so the .os.getEnv can find the API key and model name, right? Okay, so we have this blog planner here, right? Like this, everything is set, I think, right? After this, what we will do is, what are the problems? Cannot be solved. Why not? Let me see after that. I will see them. Okay. How can I run this agent? Okay. Okay, let me try to run this, right? Let me ADK web. Let me try to run this. What happened? Okay. Okay. Let me go for the source. .env. Then pivot. What happened? Okay, like this. ADK web. Let me try to run this. Okay, what happened, guys? UV run ADK web. Can I go for this? Okay. Alright. We have to put a review. Let me follow this command. Okay. Let me run. Write a blog about how AI agents can transform the banking industry. Okay. What is this going for? A write blog about AI. So this is the session state, right? Artifacts, no artifacts right now. Okay. info, there is no info. Okay, let it run. Traces, no. Events, visualization. What happening, guys? So it's loading 200. Okay, so I think API is working. I don't know what's happening, but okay. Let me check this. So event ID, location ID, branch, timestamp, state, what is state? State is display name only. And transform banking history. Okay, what are the folks now? Okay. Is this running or not, guys? Okay. So first let me check this. Copy here. Let me check why it's showing these problems. Oh. What happened? Okay. Okay. Let me see. What happened? So these commands I will run. Okay. And I will rerun this here. Okay. So how AI agents can transform banking industry. Write a blog about it. What's happening now? Let me check. Shut down the server, Control C, update priority ammo, okay. Okay. 3.120, alright. Project POTMO. Here it is. Python download. Okay, like, okay, alright. Then what after that? Okay, I'm gonna go this over here. Alright. Yeah. Then what we do, we run it to add how AI agents can transform the industry. Write blog about it, right? Okay. Now what's happening, guys? I think again it's right. What's happening? know how it can be. I want to say where. Oh, 1, 2, I think. Right. Okay. Alright. Okay, I can. I think this time it's working fine. I think so. Radiant. How agents can transform the banking industry. Right now about it like that. What happened now is now, so everywhere is 3.12, 3.12 whatever. Okay. Alright. Oh. Okay. Write the blog about it. I just read this, guys. I just need this, but okay. Okay, so Control Shift P I have to do. Shift P, pattern repeated. Okay. Delete solve it. No. Shift P, pattern repeated. What is the path here? This is the path, right? Okay. So we are showing this. Where is it? Check. Working on it. I have this. You see here, and I will run this here. What's happening now, guys? Oh, I think it's a mess, guys. Okay, now all our result problems. Okay, let me see. Let me forward. Now what is the problem? Current problem is there is always problems. Why? Okay. Let's see. Okay, this is done. Okay, we then what? Okay. Okay, let me hide it from you guys, right? The API key. I will hide it from you. Okay, so let me check. Now you guys can see, right? Now after this, okay, I need to run this. Okay, guys, let me go with this. 1 second, let me check. It's all broken, guys. What can I do? You can run it live, guys. Okay, I have to go because this is how you build AI agent, but you can resolve it using AI also, right? As I am resolving, so that's not a big deal, and I will resolve it if it runs. I will. Okay, I think I exposed my pages, so very bad of me, but I was thinking. So guys, I am going to okay. Let's listen to stream.